Today's lesson is finally we're getting into the new stuff. This is exciting. We've done a lot of review on solving expression or simplifying expressions, solving equations in the form of ax equals b. The homework that goes along with this is the quiz and code. And what is the title of this picture? There will be no spoilers here, but we will talk about how to do it. So let's talk with the notes. This typically corresponds with 10.2 in the textbook, solving ax plus b equals cx plus d. So here you're going to notice that we've got equations with variable terms on both sides. This is what makes it new and exciting. A lot of what you're about to hear is going to sound very, very, very similar because the equation solving process that we've taught you is to emphasize what's going to always work. And so we build a little and build a little and build a little. So today we're really only adding one minor twist. The goal is always going to remain the same. I hope you guys remember it. It was an activity in the classroom until someone actually exited the classroom. It is to, starts with an I, isolate the variable. We aren't finished until we've isolated the variable. So the things that we've done in the past are going to remain the same. We're going to continue to add the opposite where necessary. And we've talked a lot about the strategy when you're distributing a negative factor. You definitely want to add the opposite. You don't always have to add the opposite. If you're worried about it, yes, you can always add the opposite. It is never wrong to always do it. The second thing we're going to do is the distributive property. If it's there, if present. Not every problem is going to have that. The third thing we're going to look to do is combine like terms. First, on the right side. And second, on the left side. And when we talk about sides, we're talking about the equal sign. Those expressions on either side of the equal sign. We are not moving across the equal sign here. We're just only looking at the left and only looking at the right. So all that's the stuff we've done before. The only new thing we're going to talk about here is now we're going to balance. And we've done a little bit of this, but we are going to add a step. We always add and subtract first. The goal of our addition and subtraction is to get our equation in the form of ax equals b, which could also be b equals ax. But what you're going to see here is all the variable terms are on one side and all the constant terms are on the other side. Now, x isn't isolated because it could have a coefficient here, but all the terms are separated. And we do that through addition and subtraction. So really what we're looking for is the variable term to equal the constant term. Or vice versa, constant equals variable. Just flipped it around. Many times students only want to put their variables on the left. It's really not a great habit to get into. You want to be able to be flexible and let the equation kind of lead you to the easiest way to solve it. As you're about to see in a minute, there's 6 different ways to kind of approach all of these. One of them is going to sing for your brain, and it's okay to be flexible, but you may end up saying constant equals variable term, and that's fine. Once you get it into the form of ax equals b, then you're going to multiply or divide using the coefficient. And that's the step that actually isolates the variable. So you're really unable to isolate the variable until the constant's on one side and the variable's on the other. That's going to be the final step. So I'm going to go to my next page because I'm going to solve the same problem, maybe 5 times. It's going to be very exciting. It's the first problem on quiz and code. So it's letter U. And the problem is 5x plus 8 equals 3x plus 20. Now, I know you're like, why do we have to solve it 5 times? Part of this becomes personal preference. So a lot of times in the class, I'd ask you, which one of these 4 terms do you want to start with? Because it really does not matter. So because I don't have you to ask, we're going to do it the way I prefer to do it first. I often prefer to deal with my variable terms first. So I'm going to look at the 5x and the 3x. I use a little bit of strategy here. I don't like negative coefficients. Why? I don't know. I think perhaps it goes into when we have inequalities and that negative coefficient causes me to flip the inequality. But regardless, I try to always have a positive coefficient where it makes sense and the numbers don't get too crazy. So I'm going to subtract 3x and subtract 3x. Now notice there was no distributive property, there was no combining like terms, I can't combine these terms, so it's time to balance the equation. 3x minus 3x gives me 0. So on this side of the equation, 0 plus 20 is just going to leave me with 20. 5x minus 3x is 2x plus 8. Now, I don't subtract 3x from both of these terms. I only have to subtract it from the entire side. And in some way, it's like combining terms here because they're both x terms, leaving me with 2x plus 8 equals 20. Well, that looks familiar because that's ax plus b equals c. We know here we're going to subtract 8. So again, we're still in that adding and subtracting stage here, leaving me with 2x equals 12. Now I'm in that form of ax equals b. I'm going to deal with that coefficient to finally isolate the variable. Dividing by 2, x equals 6. So we're going to solve it a bunch of different ways. We're still going to get x equals 6 if we wanted to check it. We'd say 5 times 6. And again, I'm coming back up here and I'm only changing the x's to 6 plus 8 should equal 3 times 6 plus 20. 30 plus 8 should equal 18 plus 20. 38 equals 38. It checks out. 6 is the correct answer. So let's go back. That's method number 1. So I took the 3x and subtracted it. Let's look at what would happen. All I'm going to do here is recopy the same problem, and I'm going to solve it differently. I'm going to subtract 5x from both sides. Mrs. Rohner, do I have to solve this multiple ways? No, you don't. But I think it's really important that you understand you can start this problem any way you want to, and you're still going to get the same answer as me. 5x minus 5x is 0, leaving me with 8 equals negative 2x plus 20. Now, I'm going to ask you a question. Do I want to deal with the 8, the negative 2, or the 20 next? Get the answer in your mind. You got a 1 in 3 chance of guessing correctly. If you said 20, you are correct because we have a variable term and a constant term. We want the variable term to be all by itself, so we're going to take this constant term, we're going to balance the equation and move it over here, which means subtracting 20 from both sides. Negative 12 equals negative 2x. Now notice, when I divide by that negative coefficient, I'm going to get 6 equals x. Same answer. I don't have to check it again, we already did. That's the second way that you could solve it. So many students really like starting with the constants. That's just personal preference, and I don't care if you start that way. So I'm going to write the problem yet again. 5x plus 8 equals 3x plus 20. Let's get rid of this 8 first. Subtracting 8, 5x equals 3x minus 12. Okay, get in your mind which number you want to work with, 5, the 3, or the 12. Actually, it's a negative 12. The number we want to work with this term here. We want to work with the 3x because we want to get all the variable terms on one side, and we only have one constant. So here's a little bit tricky, equals. So this is 0 minus 12. Remember, if I add the opposite here, I have negative 12. I did that wrong, didn't I? Copy this down. It should be a positive 12. I'm looking at it going, I'm going to get negative 6. Nope, that should have been plus. I hope you guys were screaming at the video when we got to that point. You're going to divide by 2. X equals 6. Whew! Thank goodness we went back. I already knew what the answer was. Now, I do want to point out something that happens here. I'm going to do this problem, and I'm going to begin it the same way. I'm going to subtract 8. Hopefully I will subtract it correctly this time. Plus 12. Now, if you went and dealt with this term and you subtracted 5x and subtracted 5x, it's not wrong to do it this way, but it adds a step. So let's look at what happens. So the equal sign comes down. On the left-hand side of this equation, we have 5x minus 5x. Well, what does that equal? 0. 3x minus 5x is negative 2x plus 12. So some students use this in order to guess and check what this number is. You can see that negative 2 times 6 plus will be negative 12 plus 12 would be 0. Or now you need to pick one of these two terms over to move so that you have a constant equals a variable or a variable equals the constant. So you're really thinking about where the terms are. This is just adding a step. I solved this one in 1, 2, 3 moves. Here it's going to take me 4 moves because I'm going to want to move something back over to here. Maybe I want to move the 12. Negative 12 equals negative 2x. And we've been here before, way up here. We'll end up with 6 equals x. But this is something that's okay to do. It's just adding a step. It's unnecessary, but mathematically it's sound to do it that way. Just make sure you understand what you're doing when you do that. The last way, I think I haven't dealt with the number 20 just yet. So 5x plus 8 equals 3x plus 20. It's going to equal x equals 6. Subtracting 20. Think in your mind what you want to use, the 5x, the negative 12, or the 3x. You can pick any one of these, but only one of them moves you closer to isolating the variable. Only moving the 5x next is the fastest way to isolate the variable. You can move the 3 over and then move something else back, but it's faster to subtract the 5x and then divide by that negative coefficient. All right, so it comes down to personal preference. When you're looking at quiz and code, if I look at M, negative 9w plus 17 equals 7 minus 4w. Personal preference. Do you want to combine? Personally, I'd probably end up adding the 4w. I don't know why. That's just where my gut wants to go, and then subtracting the 17. Some students will do this in only one move. Let me copy M down, which is okay with me. Negative 9w plus 17 equals 7 minus 4w. I did it by showing all that work. Some of you are going to get fast enough. I said I wanted to add 4w and add 4w. Some of you are going to get fast enough rather than bringing these terms down. You know, if you're moving the 4 over to here, you're going to move the 17 over to here. You can show all of that in one and get 5w, negative 5w. That one goes away, equals, this one goes away, negative 10w equals 2. So negative 9 times 2 plus 17 should equal 7 minus 4 times 2. Negative 18 plus 17 is negative 1. Checks out. So I showed it all in one step here. If that's too confusing, please show the work. I've solved about 4,000 of these. You are only beginning. When you've gotten to 4,000, you can start simplifying things. There's nothing wrong with showing these 2 steps, especially if it keeps your work nice and organized. This is exactly the same as this, with the exception of I broke these 2 steps and put them all here. Don't care how you do it, but I do think us big writers are not going to have the space that we need in order to show all of our work. So you're probably going to need to work on a blank piece of paper. Enjoy.